Welcome to night 6. So next week will be our last week. We will do Monday as normal, talk about parameters and stuff like that. We're actually not going to have an assignment tonight, so should be able to get done a little early again, which is awesome because we're going to have a guest lecturer come for a normal storytelling time on Monday. A guy that works at Builder Trend, and he is one of the guys that implemented Domo. So we use Tableau and Domo at Builder Trend. Tableau for all our internal basic analytics, Domo for our like embedded external analytics for customers and stuff like that. So I'm going to have him come for the first half hour or so and just walk you guys through a lot of the same stuff that we've been doing in Tableau, bar charts, line charts, how to bring data and stuff like that. The goal of that being, and I've stressed this to like every person I've talked to when they ask me like what tool they should buy, and like every person I've interviewed is like, once you know one, you kind of know them all. So the goal of having him to come in and show you guys Domo is if you're ever to interview or talk to someone and they're like, well, we use Domo, do you know that? And you say, well, I'm really proficient in Tableau. I've seen Domo a couple times once, and I'm very confident I can pick it up really easy because they really are very similar. But there's some key differences and stuff, and we'll cover those. So no assignment tonight, guest lecture on Monday to talk about Domo. And then Wednesday will be our very last night. We will cover, essentially I'll just like kind of build a dashboard live and show you guys kind of requirements and then walk around and help you guys build it. I'll do our final project, we'll call it good. I'm gonna have Nate come on Wednesday to talk about next steps after this, as far as like, I actually think we'll bring certificates here for this class and then talk about the next classes that you guys will be in based on what track you're in and stuff like that. And I know, Melinda, you were asking about some of the internship opportunities that you talked about, so he'll talk through those as well too. So wrapping up very quickly, and I really like where we're at. I think tonight will be one of the coolest nights that we've had so far. We're gonna be talking about analytics pane in Tableau, which I'll get into in a bit. But first, for some storytelling, I'm gonna have probably you three here come up if you don't mind. The other people that sent me their homework are not on the stream yet. Bianca, I appreciate you sending me yours, but I noticed there's some financial data in there, so I figured probably not record that and put it up on YouTube. But I appreciate you sending it across. It looked great. I love that at least one person did a budget, because if I'm like a dream Saturday with nothing to do and I could just like build something out for fun, it'd be a budget for myself. So good work there.
Dream Saturday?
Oh yeah. Well, actually, Melinda and I were talking about before you guys got here. My
I got
dreams.
to organize the storage closet at my work today. I was so happy.
My dream Saturday is all day cleaning. Like give me a nice storage closet or something, and my serotonin levels would just be at an all-time high. Cool. Who wants to go first between you three? Melinda, sweet. Thank you.
Okay.
Sorry for my 1,000 words.
No, you're fine. So I just kind of did like a food tracker. I used to do this a lot when I first started on my like fitness journey, and then I kind of slacked off for a while. So this kind of motivated me like to get back into it. I did use like another app, but I kind of focused this on my protein intake to make sure that I was getting everything every day and keeping up with that. So I just did a simple Excel with, you know, the food the date, the food I was eating, what meal it was for, the calories in it, and the grams of protein. So I just kind of kept it simple. So the first chart, I just basically did like how much protein am I getting each day, and then I filtered it by meal. So I could see that maybe, oh my gosh, I get all my protein in the morning or all at night. So I was just kind of thinking about that. And then I figured out how to add a constant reference line, I think it's called, to show where 100 is, because that's at least what I want to hit every day. I want to get more than that, but that's at least where I want to hit. So just to kind of have like a little weight threshold gauge on there. And then I took the same information and I broke it down a couple different ways. So first I did how many calories per day I was getting per meal. So I don't know why it's cut off, but there's also dinner, like the color coding. It's weird. But anyway, so it would show like each meal and kind of where my calories are coming from. And then the next one, I kind of reworked it a little bit, and it's each of the yellow, pink, and gray are like the 3 different days I started going. And so I'm looking at how many calories I was eating at different meals and then at different days. So I don't know how useful that is, but I thought it was an interesting way to look at it. So I could just kind of see like, maybe if there's a day that I was super high or super low, like, what was going on that day? I don't know. So that was just,
I love it. What's the app you use to track this?
oh, I just did a Google sheet.
No, I mean like,
Oh, my other app that I
Yeah.
do, it's called Lose It.
oh, sweet.
And you can kind of save foods in there, especially foods you eat often, and it breaks down, you can break down by all the micronutrients and stuff. And so it's nice. And when you hit milestones, when you lose weight, it has like, you lost, it was like, one was like, you lost the weight of a guitar. And it was like, what? So I kind of like that. That has a lot more features and stuff, but now that I kind of have this, I might be able to take some of that info that I'm just kind of inputting and find other ways to use it that might help me, I don't know, just kind of see how I'm doing in a different way, so.
Yeah.
Yeah.
I love it. A lot of times, like apps and stuff like that will have just Google, like how to request my data from certain apps. A lot of them
Yeah,
have,
exported,
requirements that they have to share that, which I love. And I've done that a few times. Like request the data, and they send you Excel. Or best case scenarios, they have like a live API that you just like plug into directly, and then all of that feeds in.
Yeah, I was going to look at exporting old data, but then that was quite a few months ago, I kind of slacked off over the winter. And so I didn't want to have a big gap when I started putting it in again. So I just started a new fresh one for community, so.
I love it.
Yeah.
Nice work. Nice. Puddles. Cool.
I can go next.
Sweet. Come on
I won't bet you.
Yeah, so mine wasn't too complicated. It's just a task list that I took from my task list or priority list. And what I do is like on my to-do list, I give them priority scores, and depending on their scores, I really like use that as a priority measure. And so I've got a couple like priority 10s where I have to get them done as soon as possible, because it's urgent and important. And then I have plan it, which are lower rankings. So I created a calculated field to say, or the conditional statement as well. So if it's above 10, it would be red, else, I plan it. And I really wanted to test the live feature, so there was a priority 10 that I wrote completed in, but I didn't make a calculated field to recognize that, so it's just blank.
Oh, nice.
Instead of a number.
Yeah.
But yeah, that's, I use that feature.
I love it.
Yeah.
All
You
right.
also have to tell them about the 0.5K, because this is the coolest event I've ever heard of.
Okay, and the dog show's cooler, I would argue, but it's a good one. So, my friends and I like themed parties quite a bit. So we have a 0.5K coming up in April, which is literally 0.5 of a kilometer. So we start at Jake's, and run through Beercade, and then finish back at my house where we do yard games and karaoke and all of that. So we have an RSVP list, and so I was tracking how many people have signed up, the number of runners that they plan to bring. So like if someone RSVP for multiple people, then we know that. The number of shirts. So this is a little bit wonky, but this is the number of runners. This is the number of shirts that they ordered, and then how much they owe, because they owe for the shots as we go through each bar and their t-shirts, and then we provide all of the beer and food at my house. And so if they've already Venmo'd me, then it is green. If they haven't Venmo'd me yet, it is red. Here's our shirt order. So once we have everyone RSVP, we can just send this over to the shirt place, and they can order all of the sizes. And then I wasn't sure how to display this because generally we don't have repeat songs requested, but we queue up a bunch of songs for karaoke ahead of time. So I thought that if there were repeats, then maybe size would come into account there, but it hopefully won't.
That's awesome. And is this, did you end up hooking this up to Google Feeds?
Yes,
Sweet. So as people pay, you can see that money come over the green and all
Yep.
every day.
exactly.
Love it. Very cool. All right. Awesome work there. I thought it was very cool walking around and seeing what everyone was building out on Monday. So let's go ahead and get into the meat and potatoes for today. So we're going to be talking about the analytics pane, as I mentioned. It was actually funny. I think there were 3 or 4 of you, Melinda being one, that actually needed this or wanted to bring this into the dashboard on Monday. It was a perfect little segue into tonight. There's a few different things in here, so we'll go through in the overview section here, and I'll just kind of talk a little bit about them, what they are, when to use them, things of that nature. And then in the second hour, as normal, we will jump into the live hands-on section. And for the people that just hopped on here that weren't in for my opening monologue here, we're not going to have an assignment tonight because we're going to have a guest lecturer on Monday come over our normal storytelling section. So analytics pane, if you guys remember like night 1 of the Tableau UI, I had like 7 different sections of Tableau that we have covered all of them, but the analytics pane up to this point. So we talked about the data sources, pulling into a sheet, formatting different stuff, building a dashboard, building a story. But the most exciting one, in my opinion, and what I nerd out on a lot, is the analytics pane. So that is located right up at the top, right beside data. You can switch over and click into that, and then instead of showing your fields, it'll show all of the different analytical options that you can bring in by default, drag and drop in Excel. So we cover this pretty much every class, but I think it's good to continue to reiterate, is the reason Data Viz is first in Omaha Data Science Academy, and the reason that I chose to use Tableau is it really teaches you the full spectrum of data science, or what I like to call a full stack data scientist. So obviously we've hit a ton on the Data Viz stuff, because that's the name of the class. We've hit a ton on how to connecting and transforming data, which is a lot of data engineering work. Last week, we talked about calculated fields and how to write formulas, which is going to be a great lead into SQL and Python and things of that nature if you continue to go down that track. And we're obviously every single night learning how to analyze data as we bring stuff in to look at trends, which is going to be kind of the data analyst track. So tonight will be an exciting one because we're going to talk a lot about the data scientist portion. So bringing in different trend lines, forecasts, k-means, clusters, a lot of the stuff that really separate data analysts from data scientists. Tableau has built-in functionality to do. So it's going to be high level enough that we're going to be able to jump in tonight and learn it in an hour. Obviously, we're not going to get super into the weeds on the concepts and the theory behind it. But when you go onto those classes or want to hobnob at different events, you'll be able to talk about them and understand what they mean and why they're impactful and useful. So exciting portion of class tonight, in my opinion. Very similar to Monday, where we'll walk through all the different examples. I think the one thing I want to call out is we do have a data science class going on right now upstairs as we speak, where you'll go into like the theory of all this. I'm not trying to understand how all of these are built out behind the scenes. But I do think it's important to continue to get reps and understand how they work in Tableau. So we're going to go through one by one and just build out a whole different ways to get our kind of brain working around the concepts around these. So this is all of them. I'm not sure why I listed them out again. So the first one, constant line. This is what Melinda had brought in her example. Let me go ahead and make this full screen. Like I said, we're just going to touch on each of these for about a minute before we pull up Tableau and start going through them. So constant line, we have our chart right here as normal. It's literally a line that you can just bring in and set to whatever value you want to set it at and use it as kind of a reference. So right here we have $50,000. You can see as the lines go above or below that, You don't have to look over to the y-axis and try to understand exactly where they're at. It just gives you, as the definition, or as the name states, a constant line. Very exciting stuff. Average line gives you a bit more flexibility. This is pane by pane, which we learned about a couple weeks ago. So all the different data points inside of each year that we're showing here, I have to assume we're showing. So we have to assume we're showing sales, since that's normally what I use, but just across that pane, where's the average of all those data points, and understanding if you're above or below average for each one. Median with quartiles. So this is like classic mean, median, mode, range type stuff. This is going to show you, similar to an average line, where the median is across those different data points. That's going to be the dark gray line in the middle here. And then it's going to give you quartiles, which is 25% above, or the next 25 percentiles above and below, to give you your different quartiles across that. So the entire thing will span 50% from the middle of your data set, or the middle of the data points that are showing in that range, to give you a little bit more granularity around not just if it's above or below average, but kind of in an acceptable range of median values. Box plot, I don't know, I feel like we all learned about this in like 3rd grade and we always called it box and whiskers. So that's what I'm going to continue to call it, is box and whiskers. But pretty similar to the median with quartiles. We're going to have your median line right here in the middle, top upper quartile, lower quartile below it. And then the whiskers on this actually go out 95%, so that they're the 95th percentile and the 5th percentile, to give you a range of any easily identifying outliers if things are kind of within the area of acceptance, and then obviously if they're inside kind of the 50th percentile in the middle of the range there. Totals, this is a super simple one, but one that I think I use on a majority of my stuff. You can bring in totals either in subtotals, but these are showing right here. So for each pane, just summing up the values inside of that pane, and then grand totals, which will sum up the entire table. So panes and tables. You can do it for your different rows. So if you get table down or pane down, to use the terminology that we learned about, or if it goes wide, you can also do table across and get totals for all your columns as well too. Confidence intervals, what this is going to do, this is a statistical term that if any of you took stats in college, I'm sure you remember messing around with confidence intervals, but it is going to tell you what the average is. And if you were to say how confident you are, that is the average, and not just a random, if your data is just randomly dispersed and you might not know if it's actually the average, or you just got lucky with the average. This will give you a confidence band around your averages. This is used a lot more in forecasting and stuff like that, which we'll get to in a bit. Median, same thing, except median instead of mean. Trend lines, this is just going to be mapping and creating a model for the data points inside of your different panes here. It actually gives you a few different options to have a linear regression trend line, to have an exponential trend line, and it will automatically map which one fits your data better. So if you want to, I'm not sure if any of you ever built a linear regression line before, not super fun to do. Tableau allows you to do it by default. And yeah, I think a lot of these will make more sense once we open up Tableau and go through them. I want to give a quick overview of what we're working with before we dive in. Forecast, this one's fun. So you can see here we have 2017, 2018, 2019, 2020. These are our different sales by those different years. We can actually forecast in 2021, and it'll give you options to forecast out 1, 2, 3, 4, 5, 6, 7 years, however we want to do. It automatically brings in seasonality. So if sales are down in January, February, looks like we normally get a pretty nasty dip in October or November, whatever this month is, it'll automatically bring that in. And then you can also see that it brings in the confidence intervals around it to show you how confident it is in this trend line. You can adjust those. So if you want to be 99% confident, it gets really wide to give you some more room for error. If you want to only be 50% confident, it shrinks it in a little bit and shows you where it should end up. but I use this a lot, really, really handy functionality. And again, building out a forecast with seasonality baked into it is not a fun thing to do by hand. It's really beneficial to have baked into Tableau. Clusters. Have any of you ever heard of k-means clustering before? So clustering is a common technique it's a machine learning model that allows you to find commonalities inside of groups of data. So a lot of times you'll have either a known variable that you're trying to train your model on. So the classic one is like the Titanic data set. It will give you if they're male or female, what class their ticket was in, how old they are, and it gives you if they survived or not. And you feed that into a model and it automatically spits out a prediction based on your input variables. Yes, they survived, no, they didn't survive. Where you use clustering is if you don't have that known variable. So it's what's called an unsupervised machine learning model. The first one is a supervised machine learning model. So you don't have if they survived or not, you just have all the input data. This machine learning model will actually go through, take those input data sets and find commonalities between them. So they'll say, here's a group of people that are under the age of 10, male, and in a standard class. Here's a group of people that are 60, female, and in a first class ticket. And it'll find these clusters automatically based on how closely they are together. And then you can go in and try to find the commonalities between them to say these people probably would have survived, these people probably wouldn't have survived. But it's what's called unsupervised. So it's we use it a lot of builder trend for like customer segmentation if we want to find types of customers that behave similarly to other types of customers. Maybe we want to predict if they're going to cancel their subscription or not. Obviously, we don't know if they did or didn't because it hasn't happened yet. So we use something like a k-means clustering model. Probably a little too in-depth for this class. The point is you can do it really easily in Tableau. So here I have sales and profits. Automatically, you can toss it in and say, find how many distinct kind of clusters of data I have. It's not super exciting when you only have 2 dimensions, profit data, like you can easily visualize this and say, okay, here's 1 cluster, here's 2, here's 3. But if you toss in 4, 5, 6, 7, 20 different data points, obviously you can't visualize that in kind of a 2D model. So Tableau will still go in and cluster those together, which is really, really cool. And k-means clustering is just like, it's everyone's favorite model. If you go to any sort of like data science meetup or something, like the most nervous I've ever been when I first started working in data science, fresh out of college, I went to like a data science meetup, and the like fun fact or icebreaker is everyone go around and say your favorite model, which is like such a nerdy icebreaker to have. And it like came to me, and k-means clustering was the only one I knew, so I was like, oh, I like k-means clustering. And everyone's like, oh yeah, great model, good job, Charlie. I was like, nailed it. So that one will always have a special place in my heart. And then reference lines is pretty easy. It's very similar to a constant line, except instead of having it be a measure, where you're setting a constant along the y-axis, it'll be a reference line that you're setting essentially a constant along the x-axis. So if we wanted to note, like, hey, this is when COVID happened in March 2020, you could toss a line in right there, and you can update your labels to call out essentially anything you want. Reference bands, similar to reference lines, but it gives you a band around them. Distribution band, same thing as a constant line, except gives you a band around it, so you're entering in 80%, 120%, whatever you want to enter in, it gives you that band. Box plot, obviously very, very similar. I think I already showed this one. In fact, I'm not sure why I have it in here twice. Maybe just built out a slightly different way. And then that's it. Any questions? Again, I know that was a super, super, super high level overview of just how the analytics pane, kind of what we're trying to do or what we're trying to accomplish inside of Tableau. No? All right, easy enough. We're not going to take a break because we're only 30 minutes in, but let's get into some of the demos. let's go ahead and open up our good old Superstore data. Let's just bring in orders. Go over to our sheet. Pull up the examples to work through here. All right, so to start out with, let's go ahead and just bring in, similar to kind of what we did towards the end of last week or on Monday, let's bring in our order date for our columns. Let's go ahead and leave it as the year. And then let's bring in order date again and change that to a month. And then bring in, let's stick with good old handy sales. All right, so we have 2014, 2015, 2016, 2017, and then our months down below, just because we're going to be using this example a lot. We're going to rinse and repeat. I'm going to go ahead and just clean it up a little bit so it doesn't bother me. Yeah, I think that's good to go. So right up here, right beside data, and here's all of our data tables and stuff, we have the analytics pane. So let's go ahead and click into that. The very first thing we'll do, super simple, is a constant line. You're going to want to drag that, and it is going to give you the options to add it either to a table, to the month of the order date, or to the sum of sales. Rarely do I go into one of the bottom two options. We will talk through that, I think, when we get to the box plot, but 99% of the time you just drop it on the table. Oh wait, maybe, I think Tableau must have updated because it didn't used to do this. So I guess if you drop it in the table, it gives you both the month of the order date. So see here, it gives us two, where we have one right here, and we have one down below here. So that's the only difference that it's doing, is if we drop it on just the month of the order date, it's going to give us these constant lines along our x-axis here, which is January 2014 by default. I'm going to go ahead and drop it on the sum of sales, and that will give us the constant line down at the bottom here. Does that make sense, kind of between the difference of you have it be on the order date or the sum of sales? Sweet. So we can go ahead and just enter in really any number you want, 50,000. And by default, now we have a constant line right at 50,000. If you want to edit this and make it look nice, because it is a data visualization class, after all, you can right click on this line and there's an edit option. And it will give you the opportunity here, see how it says the entire table. You can go per pane, which we've talked about, and update all of those individually, or per cell, which is going to be every single data point. But since it's just one line, it doesn't really matter. I'm going to keep it at the entire table. We can change the value. So if we want it to be 40,000, we can type that in. The label, you have the opportunity to either say the value that we're showing, which is why it's showing 50,000 right now. If we want it to be the computation, I don't think those work for, if we had our average line, if we wanted it to be like a meeting or something like that, we would change it to the computation. Or we would toss in a custom label and type in something like, this is our monthly goal. And then it would update to be that. So it gives you a little bit of flexibility. I'm going to go ahead and just go back to the value, which is 50,000. And then obviously you can mess around with the tooltip like anything else as well too. If you want to fill it in, this is just really ugly. Obviously we would want it to look like that, but you can fill in everything above. Or what I've done a couple times before is like fill in stuff below it. So you can see months that you got above whatever your constant line is. But good old data ink ratio, probably not the best thing to do. So constant line, pretty simple. No need to mess with perfection. So I'm just gonna leave it kind of as is. I'm gonna make sure to publish all our examples tonight, so I'm gonna keep it like this. Any questions on constant lines? Cool. Let's duplicate it. To get rid of these things, sometimes they're kind of tricky. The easiest way that I've found is just hover over it, drag it off to the side. You'll see that little red X pop up, and that gets rid of it.
Can you do that one more time? Sorry.
Just grab the line itself.
Oh,
On the side. So average line. Go over to analytics, bring this in. So now it's going to give us the opportunity, a few different options again, table, pane, and cell. Let's go through each one of those. If we drop it on the table, this is going to be the average across all 4 years that we're showing here. And hover over, you can see the average is 47,000. If we were to, I just hit back, bring that in on the pane level. Again, we're familiar with panes now, so we have 2014, 2015, 2016, 2017, and 4 different averages that you can hover over to see what they are. Or we could bring it in at the cell level, and this is, in this instance, the cell and the pane are the same because we don't have, if we had like subcategories or something like this inside of here, it would give us another layer of granularity down. But since they are the same all the way across the panes here, this is gonna stay as is. So let's go ahead and keep that just at the pane level. So here, if we click into edit, again, that's just a right click edit. See how this one by default, the label is showing the computation. That's what I was talking about with that constant line. So that's why it's showing average. Typically what I'll do is either do just the value, which is going to change those to actual values so they don't have to hover. But sometimes I don't think that gives a whole lot of context into like what this random line is on my chart. So this is an instance where I'm actually going to click in and hit custom. And this gives us the opportunity to, one, type to give a little more definition. So I normally condense down average a bit. But then if you click this arrow here, it gives you those same options that you had before. So then you can add in value. And now it gives you kind of a nice combination of the both where you can see the average is 40,000, the average is 61,000, so on and so forth. Cool. Another really cool thing here that I actually use a lot is this little checkbox here. It says show recalculated line for highlighted or selected data points. So I wanted to go in and say, what was my average for the last 1, 2, 3, 4, 5, 6 months of the year? When I hover over those, you can see this average line pops up. It says 53,000. You still have your original average line down below here, but that allows you the ability to kind of mess around. If you don't want that to happen, obviously you just uncheck this box. But it's kind of cool, native built-in functionality. So I'm going to leave it on. Average lines. Let's go ahead and duplicate. This is going to be a median with quartiles. All right. Same thing as before, drag off that average line, bring in the median with quartiles, and let's drop it on the pane again. And now by default, we have our median, we have our quartiles, which is 50%, or the 50th percentile above, 50th percentile below. It took me this long in here to keep the grid lines, but now they're starting to look really ugly behind that gray. So I am going to go format rows, it's called lines, rows, and remove those grid lines. So it's a little bit cleaner here. And then let's go ahead and click edit. And I'm going to do the same thing as before, where I'm going to change this to be the custom. I'm gonna type in median. Then hit this little arrow and do the value. So we got those that way. And then what I like to do when anytime I'm showing just like some shading, just like when we right click this and hit edit, you can also right click and hit format. And then that gives you the opportunity to change the shading color. So if I wanted to go like a nice pretty, whoops, that's the wrong area actually. That's not it. Give me 1 second. I know you can change that color. Now, when we take our break, I'll Google that and come back to you. Because I think that the gray line is kind of ugly and not very on brand. Yeah, meeting with Quartiles. All right, now to switch it up a little bit, instead of duplicating this, let's create a new sheet.
A question.
Yes.
So my quartiles are around the overall average, whereas it looks like your quartiles are around the average per pane.
Mm-hmm.
But my median line is set to pane, so I'm not sure.
Interesting. Let me see. It may have just been, there may have been something weird in the background when you duplicated the sheet over that we just didn't get rid of.
Okay.
Still working for you.
I think so.
Yeah. Here you are. All right, so let's start a new sheet here. And let's bring in my example I have, at least we have region for the columns. And then sales rows. And then let's just go ahead and drag subcategory onto the colors. And it gives us this really ugly stacked bar chart. So let's change that to, I don't know what we're gonna do there. Let's just change it in the marks tab from being automatic to a circle. And probably let's change it to be a shape. The only real difference is circles are, as the name suggests, circles. Shapes, it actually gives you the ability, see when you select shapes, you get a new little tab in our marks card that we don't normally have. It's very similar to just our color type view. If you hit edit shapes, it gives you some default shapes. And then there's a few different things. A really kind of cool thing about Tableau is you can also upload your own shapes. So I don't think I have any. I have a few different shapes that I've added in here for Builder Trend. So if you wanted to build your like a branded type website with your own default shapes and things like that. You can do that, but we're just gonna keep it as circles. So let's go back to our analytics tab and bring in the box plot and drop them in on cells. So this gives us, again, you can hover, actually this is kind of a good example of, there we go. If you hover over here, it gives you the median, upper hinge, lower hinge, which again is just your 25th percentile up and down for the median, and then upper whisker and lower whisker. If you click into that, it will give you some options of what you want the whiskers to extend out to. Something I typically do, if I'm trying to show something like this, really what I'm just trying to show is these are a really wide range, or these are pretty close to each other. This is where like averages and medians can get a little misleading when you have this much data. So sometimes what I'll do is I'll hide the underlying marks, which just cleans it up a little bit. And so then you can see if I were to show this to a sales guy or something like that, I could say, you know, on the medians for each of these, there's definitely differences between them. But if you look at the band across the kind of inner quartile range, they're fairly close. There are a few outliers for each. And then selecting that checkbox doesn't actually hide the outliers. So you can see like, geez, chairs in the central region are just going through the roof right now. It also has, and this is actually what I was looking for in that last view with the banding. For the fill, you can change the colors as well too. So I typically choose something prettier than just gray. Or the thickness of your line and stuff like that. It gives you a little flexibility to make it look a little prettier.
How'd you get rid of the data points?
Yep, if you click edit on this, there's a checkbox that says hide underlying data.
That's right.
All this. Cool. You could also, if you didn't want to hide the data but wanted to clean it up a little bit, sometimes what I'll do is I'll click into the size option here on the marks. You just drag this down a bit, not that far. So you still have your circles behind, but it's a little bit easier over the hover options that you want. And you can kind of see the distribution of those data points without actually hiding them completely.
Can you show where the connects?
Yep, right here in size. You can mess around with the size of your circles here. All right, let's go ahead and start another new sheet. Let's do category on the rows, subcategory right beside it, and then let's do region along the columns, just so we have a few, go something wide and long here, and then drag some sales onto the text here. So here's a little table. We're very familiar with the panes and table down, table across, things like that. If I were to go into analytics, you can see that the other nice thing, similar to like the show me, is it grays out if you don't have the necessary data to do one of these things. If I drag totals over here, I'm going to have three options: subtotals, grand totals for the columns, and grand totals for the rows. If I were to drag it onto subtotals, this is just going to give the total for my pane for each of these. So for central, here's my total. For furniture, for office supplies, here's my total for technology. I can drag it over again and toss it onto column grand totals. And then this is obviously summing up the entire table, not just individual panes. And then if I were to drag this onto rows, I can have grand totals across the rows as well too. Very, very handy. I use it a lot. if you, right click and hit format, you can change the total or the label for each of these. So sometimes I'll go in and just make it a little bit, more descriptive, say like total sales. Or maybe, category sales would be a good one here for the subtotals, and then the grand total. I think I can update that too. Yeah.
Nothing much shifted or changed yet.
With what?
Or is it because I'm on
So I'm not sure why it wasn't, because you were over here. I think they'd be the same, but sometimes depending on what you click filter on, they'll look the same, but actually be represent something else. So I'm not sure what this is actually saying.
I think it might be just because region category or column. It's a column.
It's here, here's the option, and then we click it here.
Yeah.
The option there.
Okay. Thank you.
All right, then the very last two before we kind of get to the fun stuff here. Is bringing in some confidence intervals. So I'm actually going to go back to this medium with Quartiles 1 and duplicate that. It's kind of a good starting spot. Yeah, go ahead and drag it off. You may have to do it a couple times with both the median and the quartiles, but get rid of those. And then if I bring in average, 95% confidence intervals, drop it onto my pane, and we get something that looks almost identical to everything else we've been doing, but slightly different here. So we have the median, the quartiles, which again is just going above or below based on what the data is. The confidence interval on the average is going to tell you if you need to be 95% confident on what the average is, if you were to add additional data points or anything like that. This is kind of give you your band. So if you have really, really tight data, your band won't be as big. As you can see here in like 2015, our maximum and our minimum is fairly relatively small. So the confidence interval is not as wide of a range. In like 2017, we have this big outlier here. So that expands the confidence interval for the average across a little bit wider. So when you use something like this, again, averages can be really, really tricky sometimes because outliers can skew it one direction or the other. Dragging in the confidence intervals on top of that is going to allow you to be certain that the average is actually close to this and it's not just being skewed one way or the other. Same thing as before, you can right click into this and edit this stuff like we've done before, but I think you guys have a pretty good grasp on that for now. So I'm gonna leave it as is.
What did you use, or what would someone ask for if they wanted a 95% confidence interval?
Typically what they say, so something I've used this on before, would be saying something like, if I want to know on average, let's do, this might actually be a better example. If we do like categories, subcategories, sales. So if they said, hey, I'm trying to show that on average, our technology makes more than our furniture. If you just pulled the averages for each of those, obviously you're gonna have just one single number for this. The confidence intervals allows you to show, is this a tight average where everything is fairly close to the average itself? Or is it being dramatically pulled up or down one direction by just a couple outliers here? So this is like really ugly to see. On both of these, all of these, the confidence intervals on the averages are really, really wide. So this is saying if we were to add in a new subcategory, you can say with 95% confidence that it would be somewhere between 356 and 14,000, which obviously is a huge range because we only have 5 in here right now. So we don't have enough data to say confidently that our average is going to continue to be in this range. If we brought in something like, let's try to get these a little tighter, like order date. So here you can see with some more data in here, let's bring these out to be, so I can get somewhere in between, I'm sure you could. But like art, for instance, is always really consistent. So the confidence interval there is going to be really tight. Binders has gone from really low to really high, so the confidence interval there is really wide.
Okay.
It just allows you to say with confidence, is the average of this or an average, if we were to add a new category to this, going to continue to be within this range? Or is it being dragged one way or the other? So if you have like customers, for instance, and you have one customer making $1 million, you can say, well, on average, how much are your customers paying you? That one would drag it up a ton, and you lose a level of obscurity behind just aggregating up to one average. So bringing in confidence intervals allows you to kind of show what the spread in that could be. That was a really rambling answer, if that makes sense.
Yes, it did.
Cool. Cool. Let's go very last one here, then we'll take a break. Let's duplicate it. Let's get rid of our average lines, and next one down, median with 95% confidence interval. Drop it onto the pane. Rename it. Again, going to be the same thing, but instead of an average, just showing median. You can actually go in and choose what you want your confidence intervals to be. So if I were to choose something like 50, you can see they get a lot tighter together. So we're not as confident that our median is going to continue to be in that range, which is why it gets a lot tighter. We want to be 100% confident. You can set this to like 99.9. And then essentially it's saying if you want to be 100% confident, you really don't have a whole lot of room to work with. And again, we could teach, well, I probably couldn't, but Emily upstairs, I'm sure will cover a full 3-hour lecture night just on confidence intervals and why you want to use them. Not the goal of this class, so I understand that I'm keeping it really, really high level, but the goal is just, within a couple sentences of what these are, how they function, and how to do them in Tableau. So then when you learn more about the theory behind them, you'll already know how to build it out from a database perspective. Cool. We will spend a lot more time on the 3 fun ones with their trend lines, forecasts, and clusters, and go through a few different examples of each of those when we come back. But let's do a quick 10-minute break, and then we'll pick up where we're on top. All right, let's go ahead and jump back in. I was actually scrolling through my slides, and on the very last slide, I have a link, which I probably should have started with. This is the article where I got most of this stuff from. So Ryan Sleeper, he is like a Tableau legend. He started his own company called Playfair Data, which I subscribe to. They do a ton of blogs and stuff like that about Tableau. He's actually, so in Tableau, they have this like status you can reach called Zen Master. Like this is a real thing that there's like, Zen Master. If you like give back to the community, build your own blog, attend Tableau conference, publish a lot of tough stuff to Tableau public, they give you the status of Tableau Zen Master, which I think is like the coolest title in the world. You're all the people that got the status in 2021. Maybe you guys were on your way to becoming Tableau Zen Masters. Anyways, Ryan Sleeper, Tableau Zen Master, created this thing, definitive guide to analytics, Pane, and Tableau. This is where I got most of my content for tonight. Last year when I built it out, super cool article. I'll shoot it in the Slack channel as well. But as I was reading this, I realized that I don't think I did a great job of summarizing. Drop this in the chat real quick. The differences between these kind of three different subcategories. So the summarized one here, this is summarizing the existing data that you have with constants, averages, medians, box plots, totals, things like that. I should have done a better job of distinguishing when we moved into the model section. So the average of 95% confidence intervals, median 95% confidence intervals. The way I described it seemed very similar to the summarizing ones. This is actually building out models underneath and giving you confidence intervals in not necessarily prediction, well, kind of predictions, if you were to add new data to your data set right now. So you asked about why someone would use a 95% confidence interval. This is for if you were to add net new data, well, how confident can you be that the average will be in line with the existing data that you have? So all the same things that I said before are still true. Your data is really widely spread. Confidence interval is going to be really widely spread because who knows if the average will actually come in there because it's really noisy data. But that's why you would use it, is for predictions or forecasting out net new data, which is why I said this model section of the analytics tab, not in the summarize section of the analytics tab. So hopefully I didn't brush over, well, I did brush over how cool it is, but that's what's going on in the background. So feel free to check out the link I sent in the Slack channel if you have additional questions. He goes through some other use cases as well too. But we will continue to trek forward with the last three in here. So let's go ahead and duplicate this one, drag our stuff off to the side. Go to analytics and bring in our trend line here. So this is what I was talking about before, where you have a few different options of things that you can do. Let's just start with a linear trend line for now. It looks really, really basic, but if you hover over this, this is actually going to give you a linear regression line. So again, not a data science class, not a modeling class, but that sales equals 159 times month of order date plus 6 exponents to 6, whatever. That is your line that you would use to chart out if it continued on this linear path, what the formula would be for that linear regression line. As you add in different months, it gets incremented, and that's how the line changes. Linear regression 101, what the R squared value is essentially just a percentile of how much variance in the data is captured by your trend line. So this is saying with this trend line, we can explain about 48% of the variance. So when you see wild things like that, obviously that's not captured by the trend line. Dips down below, things like that, not captured by the trend line. But about half the data is, about 48%, because it goes up and to the right. You can see some of these, this one isn't as wild, so the variance captured by this trend line is about 62%, 68% on this one, very good. And then the p-value is kind of like a confidence interval. Is this trend line statistically significant or not? So again, this isn't a stats class, but anything less than 0.05 is generally accepted as being statistically significant. If we had a trend line that, I'm trying to think if there's a way to make this look bad easily. So this p-value here, yes, it goes down to the right. But since there's not enough data, there's only 5 data points, you wouldn't say this is statistically significant. In fact, none of these are, because there's just not enough data in there. So again, we don't need to get super in the weeds here, but that's when you hover over what these different trend lines mean. This is just a simple linear regression one, so we don't have to worry about too much more other than this is how you plot those out. I think, Laura, you and I were working with one the other day where I showed you this, where we brought in profits and sales. Where we had this scatter plot, same sort of thing. You can bring in a trend line here, and it will show you that same linear regression line with the R squared. So about 17% of the data is not great, is explained with this trend line, p-value of 0.09. So you would say this is not statistically significant. But these would be kind of the 2 use cases, either something over time or a scatter plot would be where you drag in trend lines to try to understand if you can model a regression like this. Now, the cool thing is a lot of times this isn't just a linear change. So if you were to bring in trend line again, you can see that you can add in like an exponential line, which will automatically map to this based on that formula behind it. Again, you can compare the R squared and the p-value to see if it matches better. So this one's 62% of the variance is explained with an exponential line. This one only about 62 to 62 for each. So they're actually pretty close. But it does look like it potentially has a little bit of an exponential curve where sales go up pretty dramatically in the later seasons of the year. And again, if it ever went up and down, maybe there is a little polynomial. We have kind of a spring season and like a winter season, it looks like. So here, 71% of the variance is explained by the line. 80% here. So I actually think the polynomial trend line may be the best fit for this specific data that we're looking at. But again, it's a lot of just kind of, I typically try it with all 5 options. If you have multiple data points in there, it will let you try the logarithmic or power one. But we don't have the data set up for that. So again, not a data science class, not a modeling class, but I just can't stress to you guys enough how hard it would be to do this by hand or in Python or something like that. So the fact that you're able to plot trend lines in Tableau is very, very cool. I know that's quick and high level. Does that make sense? Do you want more detail, less detail?
This might be a dumb question.
No dumb questions.
So like, if I build this for someone, they say, I want to see a trend, would they be like, I want a polynomial trend for these years? And then would I be expected to interpret this, or, because I don't, like this is like the p-squared, like I don't know any of that thing. So what's my role in creating this? Does that make sense?
No, yeah, it absolutely does. I think
it just makes me very overwhelmed and anxious.
I think
Making it is not the problem.
I don't think this is generally something that you would use for a forward-facing dashboard. Like, no one would say, give me a trend line for this data.
Okay.
A lot of times when I do use it to put into dashboards that I'm going to be presenting, it's typically in something like this, where I'm just trying to show, hey, look, these are correlated together as sales goes up, profit goes up. In fact, I bet if we toss in like discount profit, I don't know, that was correlated, fake data. But it's something real high level like this. Now, where you would try to like really fit the line and like understand the R square and the p-value and stuff like that would be if you wanted to start predicting data. So this is, again, why they're in the kind of the model section here. We could take this line. In fact, we could actually, let's just do it real quick. I copy this over, yeah. So let's open up Excel. Well, you guys don't have to, but I'm gonna open up Excel. Let's do, so I grabbed that linear regression line from my table. This is, again, building a model, building a linear regression model based on the data that we have. And what this is saying is profit, if you're going to try to predict profit based on your sales, this would be the line that best fits the data that you have. So you say, I'm going to try to do 50,000 in sales. This would be your predicted value of what your profit is going to be.
Okay.
If I wanted to do 100,000, whatever that number is, and let me just make sure I'm saying that the right way, in sales. So I'm plugging in my sales variable. I'm getting a predicted profit variable.
So it's kind of like a ratio.
A ratio would be, yeah, in this
Okay.
instance.
I guess I'm just not sure, like, to what extent I'm supposed to explain the task.
Yeah,
So
I don't think anyone would ever ask you to explain
Okay.
this. They would just say, or you would just say, this line is showing the correlation between the two
Okay.
data.
Yeah, well,
Or
that
this line
part
is-
makes sense.
is-
I get what it's doing. It's just, if I had to explain it in more detail, that makes sense.
Yeah.
So,
I don't think anyone that you present to would ask for more detail in a business standpoint.
okay,
And if you were in like a data science conference or something you're presenting, you probably wouldn't present a Tableau trend line anyways. You would actually build it out in Python and be able to present it. So
sure.
this is,
Okay.
at the level that we're at right now, you know way more than you should.
Okay,
So you don't have to worry about feeling anxious or anything like that. This is definitely more detail than you would need
okay,
to know
okay, good.
for a data visualization class. But it is cool to like start messing around with predictions and stuff. I think a lot of times, technically a linear regression is a machine learning model, no matter what people try to tell you. All it is given this data point, predict what the output would be. That's all a linear regression is doing. So you can actually all say that you are proficient in machine learning now. But yeah, so I actually use the best fit model for stuff like this all the time. Is let's say we get another 100,000 sales, what's our profit going to be? Now, the p-value isn't less than 0.05, so technically this isn't a statistically significant model, and not very much of the variance of the data is explained. So this isn't a great trend line, so I wouldn't actually probably do that, but that would be the use case for when you would need to know the detail. When you don't need to know the details, when you're just presenting a dashboard and just trying to show, hey, these are correlated together.
Sorry to derail.
What do you say?
I said, sorry to derail the.
No, that's very good. Any other questions on trend lines, use cases, models? All right, let's go to, let me rename this real quick. Let's go ahead and duplicate this one. Sorry, I'm gonna rename this too. Oops. Okay, so here's a duplicated view. I drag the trend lines off to the side. Let's go back to analytics and bring it in a forecast. Only one option here. Bring it in, and now it is showing, we had 4 years of data, 2014 through 2017. It is showing the forecasted 2018 data as well too. You can see that it automatically drops in the forecast indicator to our color pane. So we have the actual values historically, and then the estimated values in the lighter blue. You can click into this, hover over forecast, and hit forecast options. And this will allow you to mess around with, if we want to do exactly 1 year in the future, if we want to bump that up to 2 years, 3 years, however many years you want to do. It will automatically bring in seasonality, which you're going to want 99% of the time, but it can give you the option to bring in without seasonality. Or if you wanted to mess around and create a custom model, which even I don't know how to do, it gives you the option there. So let's just keep it on automatic. And then again, to the confidence intervals thing, when you get into predictions, it's always good to include a little sale or fail safe of saying, hey, this is what we think the prediction is going to be based on the forecast. But we can, if we want to be 95% confident, it could be anywhere between these ranges here. If you wanted to mess with that, again, it's just hovering over the forecast and going to forecast options. You can change that to 90%, which is going to get a little tighter. You can change it to 99%, which is going to get a little wider. But I'd say 95% is kind of the default there. And again, if you are presenting this to someone, they're not going to ask for that detail. You're just going to be able to say, hey, build a forecast. We're going to expect sales in December to be around 103,000 based on historical data. But you will learn all about building out different forecasts with and without seasonality in later classes, I'm sure. And you can see as you go further out, your 95% confidence intervals get a little wider because you're predicting further out in the future, so you can't be as sure, which is why this kind of shading band gets wider into 2019. Any questions on the forecast? Cool. So then, very last one. Let's see. Will be clusters. So let's go ahead and just do sales and profit. And let's do let's do individual orders on the detail. And then I hate the way that's showing right here, so I'm going to flip the axes. So here is all of our different orders in the sale and the profit of each. If I go to analytics, I can bring cluster on here, drag it in. Now this is what I was talking about earlier, where clusters in a two-dimensional space seem very, very simple and rudimentary, where you can just kind of look at it. But let's say we wanted to find commonalities between the discounts that we were offering, the state in which the order occurred, the category that happened. It's very hard to visualize that and just say, hey, these are close together, these are close together, these are close together. What this is doing behind the scenes, and this is another machine learning model, k-means clustering, it is going and finding the tightest groupings in 5, 6, 7 different dimensions and clustering those together. So right now we're just bringing in profit and sales, so it's very easy to visualize here, but we can bring in additional data points as well too. If we wanted to bring in quantity and, well, even with quantity there, now you can see in the two-dimensional space that we're looking at just profit and sales, there's something else going on to bring in the commonalities between these that's no longer explained in a 2D space. So this would be used, again, for prediction models if we were trying to, didn't know the output, and we're trying to create some sort of predictions. But for right now, let's keep it simple here and just have profit and sales. By default, it will find the number of clusters. I'm trying really hard not to get into the weeds here, but it will essentially look at kind of the point of diminished returns. It'll continue to try to add as many clusters until the tightness of those clusters stops being as close knit. So it wants as few clusters as possible with keeping them all tight. Is the easiest way to say that. So this is saying right now there's 4 clusters in there. You can make 5, but now like the green ones, there's essentially just 2 data points in there. That would be in the 5th cluster. So it's saying it's not really worth it. It is a slightly better model, but not really worth it to have 5 clusters. You could also go with something less, like 2. And now this is saying, yes, there's only 2 clusters, so maybe it's easier to understand, but there's a ton of, these aren't very close knit at all. So the goal is to have them super close knit with as few clusters as possible, so we keep this as automatic. I will send a follow-up, like Medium article or something that goes through and explains when and why to use k-means clustering. The one example of when I've used this in work was, again, we were trying to build a churn predictor. So churn is when people cancel their subscription. All of our customers are active right now. They haven't canceled their subscription, obviously. So one way to build a churn model, which I'd say is very common in like SaaS businesses, is you can look historically and you have, did they churn or did they not churn, and build a model based on that. So feed in the known variable, churn, not churn, look at all the data points of those customers and spit out a model based on that, using like a random forest or something. But what's difficult about that is you have a lot of customers that maybe have not churned or have not canceled their subscription, but they will. So it skews your model a little bit, what's known as survivorship bias. So another way to do it is look at all of your active customers and try to find commonalities between them. And again, it's an unsupervised model, so you don't have good customer, bad customer, will churn, won't churn, or anything like that. You just toss all the data in and say, find me my clusters of data based on the current customers I have. So in our instance, it's actually split out 5 clusters, which was really convenient for us from a branding perspective. So we called it 1-star customer, 2-star customers, 3-star customers, 4-star, 5-star customers, based on the data points that are in there. Then we can dive in and start analyzing those clusters and saying, okay, cluster number 5, they use the product a lot, they're paying us a lot of money, they've been with us a long time. That's why we call them 5-star customers. because we don't think that they are going to churn based on the data that's in there. The one-star customers, maybe they're on a free trial, they just signed up last week. We think that they're probably, those are the commonalities that the cluster found. We think that they are probably going to churn. So it's not really, I want to stress that it's not necessarily a visualization technique. Like you wouldn't toss this in there and like present it. It is a machine learning model that Tableau has built-in capabilities to do, and you will learn more about it in the data science class, but I think it's kind of cool. Did that make any sense, or am I rambling?
No, I think it makes sense. So you threw it in here for it to identify the clusters.
Mm-hmm.
So can you just throw customer ID in there and not have a second dimension? Like what were your two dimensions to create?
Right now, it's just looking at profit and sales, so you can easily see kind of where those.
So when you threw in just all your customers, what do you throw in?
So each data point, each little circle on here is a customer, or I guess is an order, sorry. So we could do, let's see. Customer ID instead of order ID here. So here it's saying that there's only, based on the customer ID, only 2 clusters here. Ones that essentially what this is saying, ones that have a lot of sales and ones that don't have very many sales. So then you could get the, if you were actually building out this model, you'd be able to feed in their historical data and it would predict which cluster that it falls into, cluster 1 or cluster 2.
So I think what I'm getting, maybe that's just essentially your question, it's like you pick a thing to measure and then you pick the 2 things to measure them by. And it says, okay, so for customers, it's like, here's all our customers. Now based on how much we sell them, how much profit to them, then we group them by like these chunks.
Mm-hmm.
So if it's order ID, it's like what orders had the best sale or clusters of sales, or if it was like region, you could do too, right?
Yep.
Like, is that what I'm
Yep.
saying? What's saying the words?
You're saying the words,
Okay.
the correct words in the correct
Oh,
order.
okay.
Yep. I think you could actually even do.
How do I want to look at
See if my guy Ryan Sleeper explained anything differently.
it? You could do like customer and maybe like sales and region of this. Is it all numerical? Okay.
I think my confusion just came from, I think I missed half of your builder trend explanation.
Yeah, the model.
Yeah. I did 2 green. 2 green ones. Cause yeah, I did like, cause I tried to put customer up here, like sales and region, and it was just in bars. And so then I just put discount instead of profit, and it did like this. I think we have to have 2 greens.
Okay.
Cause it's just, yeah, I think it's like, I wanna study this group of things, and it's like, how do I study them? And so like, you have to have like a numerical correlation to like create. That's what I'm gathering,
That
but
makes sense.
maybe not the right things.
No, it makes sense.
Yeah, the little number sign. Well, I guess we're gonna use numbers. Just easy numbers.
So this is, if we have in here, and again, I'll do one more ramble here and then we'll move on to clusters, because again, this isn't an ML course. So I tossed in profit, sales, discount, and quantity. So it's telling me that there's just two distinct clusters here. Right now, if we were just looking at profit and sales, the fact that these are all mixed in tells me that there is more kind of level of granularity or detail outside of just profit and sales that are connecting these different orders that make them like each other. So if we were just looking at profit and sales, oops, what did I just do? If we were just looking at profit and sales, very easy to identify the clusters here. But if I want to get more in depth and say, what is really alike about these different orders? So I bring in all the data points that I have. It's telling me that it can really only find two clusters, which is fine. If I click in and do describe clusters, it's going to tell us what the center of each cluster is. So when we had just our four here, just profit and sales, the center is essentially what is the middle point of these clusters. But now we have a lot of data points in there, both four. And so you can't easily visualize what is alike about them. So this is describing what the centers are of this four-dimensional kind of space that you have. And so you can see cluster one is higher in profit, higher in sales, lower in discount, and lower in quantity. So what this is telling me is when people are only ordering one or two things or five things in this instance, they're not getting a big discount. So you're getting more sales and more profit. However, maybe people are buying things in bulk. You're buying 16 at a time. We're giving them big discounts on those bulk orders. So we're getting less total sales and less total profit. That would be how I would interpret these two clusters. Again, because it's unsupervised model, so it's not telling you good or bad or anything like that. It's just saying there's two clusters of similar data points behind them. So then you still have to go in and analyze them. And I would say these are our bulk orders, and these are our one-off orders. Is kind of how I would interpret these. And then you can feed in based on, you could actually build out your own model. So when an order comes in, you would automatically classify it as this was a bulk order, this was a one-off order, without actually having that data point. You're building a model to predict which cluster is going to be. So then maybe you could say you would actually use this model in the real world by saying, hey, if this data point comes in, this order comes in with these data points, we're going to give this priority shipping because we think it's a bulk order. If this data point comes in, this order comes in, we think it's a one-off order, so we're not going to give it priority shipping. We can expect a lot of profit from these. We can expect a lot of profit from these. Again, you would typically spend like 6 months to a year building out one of these types of models and really analyzing, understanding everything about it before you put it into production. So if you don't explain or don't understand it in the 10-minute explanation I'm giving, totally fine. I will promise my homework for tonight will be to send some really cool k-means clustering articles if you guys are interested in some other real world examples of when you use this.
So this is an ANOVA of those. So is this comparing the two clusters to each other? That F statistic is comparing cluster 1 to cluster 2 for quantity, and then it's
Your
separate
individual
ANOVA.
Yep.
Okay.
Your psychology?
Mm-hmm.
Okay, so you're used to ANOVAs and t-tests and things like that.
Yeah.
Oh, perfect. I could have you come up here and teach those. It's all the same stuff. People think one of my biggest gripes with data science is they think that they are doing, and I'm saying this about myself, like original work. And like people like to hide behind like this fancy like machine learning term and gatekeep it and be like only data scientists can do this stuff. It's like, it's just statistics at its core. Like Hadoop, t-tests, linear regressions, every college stats class teaches these. It's all machine learning. It's all feeding data points and getting an output. But you do have some more in-depth types of models to work with, like k-means clustering, but at its core, it's all the same type of stuff.
So your example, I think what I missed in the example was, I thought I heard you say you just threw your customers in, but you were throwing variables about your customers into
Correct.
this model and looking at, okay. I
Yeah.
was like, what are you comparing it to then?
Yeah, so we had, probably, at that time, 50,000 customers, and we tossed in probably 10 to 15 different data points. And again, it spat out 5 different clusters. That's the easy part. Then you dive into the clusters and see what the commonalities are. You look historically how those clusters performed, and you figure out your hypotheses and what you're going to do with those clusters based on that 6 months of analysis of them. Then you can say cluster 3 here are our best customers, so we're going to call them the 5 stars. Cluster 1 is our worst customer, so we're going to call them the 1 stars. And then you start building out when a new customer comes in and it has these data points. We can automatically classify them as 1, 2, 3, 4, 5 and take different actions based on that prediction and not wait until they either turned or didn't turn. We start treating them differently before the output variable happens, which is cool. Cool. Clusters. Hell yeah. Okay. That is it from the model perspective. I think that we can go ahead. We have 15 minutes left. Let's go ahead and crank through these last 4 because they are very, very similar to kind of the summarized ones. Instead of summarizing our data, we are adding in different references on our view of the data. So like a constant line in my mind probably should be down here. But they're very easy. We'll crank through them quickly. And again, no assignment tonight because we have some coming on Monday, so we can get out here a little early. Again, back-to-back nights, great week. So a reference line, let's go ahead and grab our one of our date lines and duplicate it as a starting point here. Let's get rid of whatever we have on there. We can, let's actually get rid of month too. Let's make this really simple. And change year, sorry. Well, if you already got rid of month, just change year to month this way. So we don't have individual panes, we just have one view now. We can go to analytics, bring in the reference line. Again, it's going to give us the opportunity to do a table. We don't have individual cells. We don't have individual panes. We don't have individual cells. So the table is really the only option. If we want it to be along the month, we can drop it right here. And it gives us this reference line on the x-axis here based on what month we want it to be on. If we were to drag it onto some sales, it'll be going this way and give us our reference line here. We already did that one, so let's drag it onto the month of the order date. And what I use these for a lot is calling out when significant things happen. So if I wanted to highlight, let's say, I don't know why that changed. It should be constant here. If I wanted to say in, Oh, that's weird. When you click on this, you should get a little like date picker thing, but mine for some reason popped up on my second screen. What's happening? Do you guys click on that to get a little date picker?
Yeah.
So just go ahead and choose whatever date you want. I'm gonna choose like January 2017. And then I will change this to, instead of the label being the value, again, I'm gonna change it to custom. And this is where I would type something in like, we're looking at sales right now, so maybe changed pricing model. And what's cool is you can bring in multiple reference lines. So I can do the same thing here. And change that to constant. Maybe in, what was that, like 2016. Maybe we could have something that said, what would be a drastic thing that happened where you change the pricing model?
Recession.
Sure, they spell it RESS. CC.
I don't know.
Good enough.
Yeah.
Sweet. So I build stuff like this a lot. Builder Trend changes their pricing models all the time. And so you constantly see these really weird spikes out of nowhere, and then these level offs out of nowhere, and then another big spike as we're like testing different things. So if you just put a chart up there, people immediately are going to be like, why is that dipping right there? Why is that spiking right there? So getting ahead of that and explaining why these different things are happening, reference lines are really good to do that. While we're at it, let's just go ahead and bring in a reference band on the same table. And let's go ahead and do it on the month of the order date again. Change it to a constant again. And we can do band from, let's do halfway through 2015. May 1st, 2015 to May 1st, 2016. And then this is just same thing, same use case as a reference line, but if it spans an area of time, obviously here we could change this to be recession starts. Recession starts, recession ends. Because obviously it didn't just happen in 1 month, so then we can get rid of this band. And now we're telling the story of this data a little bit better. Recession started here, it ended here. We changed our pricing model here, and we saw sales go through the roof. So just a way of explaining the data before you present to someone, immediately they ask the obvious question. Okay, let's rename that. And then our last two here, duplicate this, drag these things off. Analytics and distribution band. Let's just go ahead and drag it on the table there. This is going to be very similar to the like meeting with Quartiles or something like that. It gives you a bit more flexibility. So the value, you can choose percentages. So this is showing 60% and 80% average. If you want to show percentiles, you can do that, quartiles, standard deviations. Let's just keep it as, oh, why did that change? As average there, maybe we want to show 60% and like 140%. So again, just some more flexibility if you wanted to say. I'm blanking on good use cases for some of these right now, but this is how you do it. All right, and then the very last one, which will go really quick because we already covered it. Actually, don't know why it has it in the summarize and the custom. I'm gonna guess with the custom we have a bit more flexibility. Nope, it's exactly the same. So box plot doubled up in there for some unknown reason. You have all the same formatting styles and options as before. So I don't think we have a lot to cover there. Any questions on, I guess specifically the reference lines for distribution bands? Cool. Okay, real quick, before we call it for the night, I am going to look ahead at what we have next week and just make sure that there's nothing that we potentially want to double up tonight since we have some extra time. I think we're actually good. So next week we are going to, on Monday, cover dashboard actions and parameters, which will give us all the tools we need to build our final dashboard. So I want to go through that real quick. So we'll cover how to build a map, which will take 30 seconds. We already know how to build a scatter plot. We already know how to make stuff look pretty. We are going to cover how to build out, being able to change, this is called a parameter here. We want to change the different things that are displaying in our dashboard. We will cover how to have dashboard actions. So when you click something, something else changes. So this will essentially give us the last two pieces of the puzzle for our final dashboard. And then next Wednesday, again, last class, is when we'll toss that all together into a self-service dashboard and call it good. So if you guys are okay with it, we'll call tonight an hour early. And again, no homework assignment. I will say, check the link I sent in the Slack channel, which again, hopefully is repeat for a lot of the stuff that we covered tonight, but does have a little bit more detail into the analytics pane. So if you want a little extra practice with tonight, since we're not doing the assignment, check that out. And then I will also probably tomorrow send a couple articles around K-means clustering if you're interested there. Otherwise, thank you guys so much for another great night and 1 week left.
Awesome.
Thank you all online as well too.